Hi everyone, welcome back to my channel Chiru's Aspirations. So today I am back with another amazing concept. Already we have covered one chapter, that is the polynomials. We are on the process and we completed real numbers also. So I'll be doing CBSE 10th standard mathematics chapter by chapter, and today I'm in the part 3 of polynomials. Already in the polynomials I did the introduction, and also in the polynomials part 2 we learned about zeros of polynomials, and today we are going to learn division of polynomials, how to divide. And the people who are new to my channel, hi, this is Chiranjeevi. I am a maths trainer and a motivational speaker. So if you want the previous videos of polynomials, you can go to the description, click the link and go to those videos, learn that and come back to this video so that we'll have a great mathematical journey. And so I am doing the 10th standard CBSE mathematics chapter by chapter, and also later on in my videos I will be coming up with the NCERT exemplar problems. Okay, so today we are going to see the division of polynomials. Already we know what is zeros of polynomials. So for a cubic polynomial it is 3 zeros of polynomials, which means graphically speaking zeros of polynomials is nothing but the curve in the coordinate system, that is in the graph, wherever the curve touches on the x-axis, so many number of zeros of polynomials will be there for that particular equation. In general, if you substitute all the zeros of polynomials in the place of x or the variable which the polynomial is, then the entire value of the polynomial will become 0. That is zeros of polynomial. Anyway, we are going to see today how to divide a polynomial. So it's simple. As we know, we learned in the real numbers the division algorithm. Okay, so whenever we divide a number, for example a, b, and this is remainder, so this is quotient and this is the remainder, right? So when we have this type of thing, we know that the dividend, this is the dividend, right? Dividend is equal to divisor into quotient plus remainder, isn't it? Yeah, so this is the relation, we know that the general division. So the divisor, the dividend will be equal to divisor into quotient plus remainder. This is dividend and this is divisor, this is quotient and this is remainder, isn't it? So this is the general relation. We know that dividend is equal to divisor into quotient. If you multiply the divisor and quotient and add the remainder, we will be getting the dividend. Similarly, the same way what we are going to do, we are going to introduce a variable x or any variable with respect to a polynomial. So let me take this dividend as p of x is equal to divisor as some q of x. Okay, let me take divisor as some a of x into quotient as q of x plus remainder as r of x, something like that. So here p of x is equal to a of x, where a of x is nothing but the divisor, p of x is nothing but the dividend, q of x is nothing but the quotient, and r of x is the remainder. So we are introducing a variable because here it is in the chapter polynomials. We are going to divide polynomials, not the real number, not just the numbers we are going to divide. We are going to divide the entire polynomial. So hence we have the relation as we know that dividend is equal to divisor into quotient plus remainder. Similarly here p of x is nothing but the dividend, p of x is equal to f of x into q of x plus r of x. So this is the relation. The similar relation here, the variable will be come. So the simple, we can take anything. Okay, so this relation here we are going to learn the problem how to divide a polynomial and also to verify the regression. Okay, so any polynomial if you take, for example, let us go to a directive problem and we will see how it's happening. So the problem is, let me take a cubic polynomial, right? X cube minus 2x plus 3 p of x and a of x, they are given by x plus 3. We need to divide this and prove the relation of dividends. So this is the equation. So you know that the polynomial with the degree 3 is the cubic polynomial. All related to degrees and different types of polynomials, all those things I have done in my previous video. You can go to the description, click the link and watch that video. Then you will have the better understanding while watching this video and learning the division of polynomials. So here this is a polynomial of degree 3, which means it is a cubic polynomial. So a linear polynomial has a 1 zeros of polynomial or 1 root. A cubic will be having 3, whereas a quadratic will be having 2. So here we will be having 3 roots. So anyway, we are not worried about the roots. Here we are going to divide this p of x by a of x. So here this becomes the dividend and this becomes the divisor. So as in the division rule, we will take as it is. Dividend will be taking inside, right? So I am going to take x cube minus 2x plus 3 inside I am taking, and the divisor is x plus 3. Now I am going to divide this polynomial. So division of real numbers is easy, whereas polynomials, observe carefully, there are simple methods we need to do. So here this is x cube minus 2x plus 3. Here I don't have the x square term, right? So whenever we don't have x square term, the general form of a cubic equation is ax cube plus bx square plus cx plus d. So this is the general form of a cubic equation or a cubic polynomial. So wherever the degree is 3, the next variable should have degree 2, the next variable 1, and finally a constant. Similarly for quadratic, it is ax square plus bx plus c. Okay, so whatever the degree we start, so it should go like this, 3, 2, 1 and a constant. But here we don't have x square term. So without x square term, we are not supposed to divide. There is a rule, always we need to consider the standard form. So here we don't have x square term. So what I am going to do, I am going to add the x square such a way that it's not affecting the value of the polynomial. So x cube plus it is 0x square. So 0x square doesn't have any value, right? So I am taking x cube plus 0x square minus 2x again plus 3. So just now I can see 3, 2, 1 and a constant. Now this is the standard form. Okay. Now what I am going to do in order to divide, take the first term of the dividend and divide by the first term of the divisor. What is the first term of the dividend? It is x cube, right? So x cube, I am going to divide by the first term of the divisor, that is x. So here 1 by 1 term will be dividing. So x and 1x gets cancelled. So the answer is x square. This x square I will be writing here in the quotient place. What did I do? The first term of the polynomial I took and I am dividing it by the first term of the divisor. So now I got x square, I wrote it in the quotient place. Now the next step what we need to do is, so I am going to multiply this single term in the quotient by entire divisor. See, x square into x is again x cube, I am going to write under the x cube. So plus x square into 3 is 3x square. Okay, so now I am going to subtract this. Observe carefully. First, what did I do? I took a single term and divided by the first term of the divisor. I got some answer. That one I wrote in the place of quotient, and again I started multiplying with the divisor. I got this. So now I am going to change the sign, which means I am going to subtract. So if I change the sign, here there is plus, I am going to write minus. Here there is plus, I am going to again write minus. Plus x cube minus x cube gets cancelled, and here I have plus and minus, both are different sign. So I will be getting, I need to subtract 0 minus 3x square is nothing but minus 3x square. And next term I will be bringing it down, this term, that is minus 2x. Now this step is over. Now what I am going to do? Now I will not consider this as the dividend. I will be considering this term as the dividend. Now 3 it is there. Let's look into it afterwards. So I have 3x minus 3x square minus 2x. Okay. Now I am going to consider this first term and again divide with the first term of the divisor, that is, here I have minus 3x square by, this is x, right? X. So x and x cancel, I will be getting minus 3x. So this minus 3x again I will be writing in the place of quotient. So minus 3x, again I am going to multiply this with the divisor, I will be writing here. minus 3x into x is minus 3x square. Minus into plus is minus. 3 3s are 9 and 3x into 3 is 9x. I hope you people are understanding. So again what I am going to do, I am going to subtract this. So here I have minus sign, I am going to change the sign plus. Here also minus, I am going to change it as plus. So minus 3x square and plus 3x square is going to get cancelled. And here I have minus and plus. The greater number sign has plus, so I am going to take plus. So since we have different signs, I am going to subtract 9 minus 2 is 7x. Now this 3 is remaining, right? I am going to bring this 3 here. Okay. Now this is the new equation. Now I am going to consider the first term of this equation or this dividend and again divide by the first term of the divisor. So here 7x by x. So x and x gets cancelled. I will be getting 7. So plus 7 I will be writing here, and plus 7 to x is plus 7x. Okay. Plus into plus is plus. 7 3s are 21. So again I will be changing sign, minus and minus. This gets cancelled and both different sign, greater number sign minus, and this is 18. So this is the final remainder. After this we are not supposed to divide because there is a condition that we should be observing the degree of the divisor and also degree of the remainder. So almost we got a constant, so we are going to stop the division. Further the division is not possible. So this way we are going to divide a polynomial given a divisor. So we divided x cube minus 2x plus 3 divided by x plus 3. So here always whenever we start to divide a polynomial, we need to look into that whether it is in the standard form. Sometimes all the terms are given but it would be jumbled, or some terms will be missing. Always we should take in the standard form, that is for quadratic it is ax square plus bx plus c, whereas for the cubic it is ax cube plus bx square plus cx plus d. Whereas for the biquadratic ax to the power of 4 plus bx cube plus cx square plus dx plus e. It goes like that. So always we should look into it and then start dividing. So here this is the quotient, this is the divisor, and this is the remainder. Now coming to the proof. Okay. So the question is, divide the polynomial and verify the relation. We need to verify the relation, right? Yeah. See, we know that dividend is equal to divisor into quotient plus remainder. So this is p of x is equal to, here divisor I have taken a of x, right? So a of x into quotient is q of x plus remainder is r of x I am taking. So it is dividend of x, divisor of x, quotient of x, and remainder of x. Okay. So now p of x should be equal to this one. This should be satisfied, right? Let me take LHS, that is equal to p of x, that is equal to, what is the equation we have? That is x cube minus 2x plus 3. Now I am going to consider RHS. So RHS is nothing but a of x into q of x plus r of x. Okay. So RHS we have a of x into q of x plus r of x. So this a of x is nothing but x plus 3, right? So I am going to write that is equal to x plus 3 a of x into, what is q of x? This is q of x, right? So this is nothing but q of x. So into x square minus 3x plus 7 plus, what is the r of x? This is r of x, right? So this is minus 18. Now we'll solve this. Now x into x square minus 3x plus 7, whenever we multiply, each single term should take and multiply the entire term. So plus 3 into x square minus 3x plus 7 minus 18. Plus into minus is minus. So that is equal to, again I am going to multiply x into x square is x cube plus into minus minus 3x into x 3x square plus 7x plus 3x square minus 9x plus 21 minus 18. So that is equal to, so we have one cube term, I'll write it here. Let me assemble all the square terms this side. So 3x square plus 3x square, and now x term plus 7x minus 9x, and finally the constant minus 21 and plus 21 minus 18. Now that is equal to x cube minus 3x square plus 3x square gets cancelled, so x square term gone, and greater number sign is minus, both are x term like terms. Now I am going to subtract this. 9 minus 7 is 2, so 2x, and greatest number sign is here plus 21 and 19. 21 minus 18 is nothing but 3. Observe carefully what happened. LHS P of x is x cube minus 2x plus 3, whereas RHS also we got x cube minus 2x plus 3. This is equal to RHS, right? So therefore from LHS and RHS, LHS equal to RHS, we have proved that, right? So this relation, that is dividend is equal to divisor into quotient plus remainder, is satisfactory, is satisfying even in the polynomials also. How beautiful is this, right? So we started divided. I taught you how to divide this polynomial by step taking individual terms, and finally we started verifying the relation, that is dividend, that is P of x is equal to A of x into Q of x plus R of x, and the quotient is nothing but Q of x and the remainder is nothing but the R of x. So when I started multiplying that and seeing that LHS was equal to RHS, hence the relation is verified. So in mathematics, whenever you start proof, you are going to communicate with the valuator, right, or some other person. So communicate in an effective way. At last you should give some sentence like this: hence the relation is verified. So this way you can take any polynomial and start divide. So the first condition you need to keep in your mind is that whatever the polynomial they have given, first cross check that whether it is in the standard form. So if it is a cubic polynomial, 3x square, then x and a constant should be there. So always focus whether it is in standard form, then go for dividing. I hope you people understood. So we know this dividing, and I'll be solving another problem, that is when we have one zeros of polynomial, then how to find the other zeros of polynomial in the process of division. Let's see that. Okay, so now we know zeros of polynomials, right? Let me take like this. If root 2 is a root of polynomial 6x cube plus root 2x square minus 10x minus 4 root 2. This is the polynomial. Okay, so this is the question. Find other roots. Okay, so this is the question. They have given a polynomial, that is 6x cube plus root 2x squared minus 10x minus 4 root 2x. So this is the standard form. It is a cubic polynomial, right? The degree is 3, x cube, x square, x and a constant. Yeah. So we need to find, they have given that for this cubic polynomial, always for a cubic polynomial we have 3 roots. For a quadratic we have 2. For biquadratic 4. So for the polynomial with the degree 5, we will be having 5 roots, which means the curve will be touching the x-axis in so many places. For quadratic equation, 2 places. For cubic, in the 3 places. So here we have a cubic equation, and also we have a root. They are given a root. So if we solve, so this polynomial, if we start substituting the values of x as 0, 1, 2 or whatever the values and start plotting the graph, you will be getting a graph such a way that the curve will be touching on the x-axis at the 3 places. So one of the place, which means the root they have given as root 2. At the place of root 2, it will be touching one of the root. So now we need to find other roots. How many roots does a cubic polynomial have? It is 3 roots, right? One root already they have given. So we need to find other 2 roots. So it's as simple. Whatever may be the roots when you find the quadratic polynomial or the cubic polynomial. So what will happen? For example, finally if we find the roots, we will be having x is equal to 2 or 3 or something. So initially it was in the factor form. For example, x minus 2 or x plus 2 is equal to 0. After solving all the simplifying the equation. So x minus 2 and x plus 2. Finally what we are going to do? I am going to separate this, and x minus 2 is equal to 0 and x plus 2 is equal to 0. So x is equal to 2 or x is equal to minus 2. What's happening here? X minus 2, the root I am going to get 2, which means the factor will be x minus 2. Similarly, if x is equal to minus 2, the factor will be x plus 2. What is happening here is, whatever the roots will be getting, so if the number goes back crossing the equal sign, then that becomes minus or plus. So that is the idea of the criteria here, what we are going to apply. So already we have a cubic equation or a cubic polynomial, we have a single root root 2. And now what we are going to do? We are going to take the factor of this particular polynomial. For example, here the root is root 2, right? So the factor will be x minus root 2. Did you follow? Are you following? Okay. So the root is root 2, one of the root of this cubic polynomial, and the factor of this is x minus root 2. Now I got a factor of this particular polynomial so that I can divide this by this, and whenever I divide a cubic polynomial by such type of divisor, I will be getting quotient as the quadratic form, the quadratic polynomial. Okay, let's do that and see what's going to happen. Now I have a root 2 and I have taken the factor that is x minus root 2. So now I am going to divide this. So 6x cube plus root 2x square minus 10x minus 4 root 2. So this one I am going to divide by x minus root 2. So how did it come to a conclusion that what is this factor? Whatever the root, just change the sign. Root 2 x minus root 2. If the root was minus root 2, x plus root 2. I hope you people are understanding, and it's very easy concept. So now similarly the same method what I am doing. So I took the first term of the dividend and divided by the first term of the divisor. So I will be doing here. Yeah, first term I will be taking 6x cube divided by first term of the x. So x cancelled, I will be getting 6x square. So this one I will be writing in the place of the quotient. Now again I am going to multiply this 6x square to x is 6x cube, plus into minus is minus. So 6x square into root 2x is 6 root 2 x square. Let us have like this. Okay. Now what I am going to do? I am going to change the sign so that I can subtract. So plus 6x cube and minus 6x cube, it is going to get cancelled. And since we have these two as a plus sign, I am going to write down. So here 1 root 2, here 6 root 2. So what happens? This becomes 7 root 2 x square. I am going to add here. Okay. 7 root 2 x square minus 10x. I am bringing this one. Okay. Now I got this term, this equation or this polynomial. Here this dividend, I will be taking this first term and again dividing the first term of the divisor, that is 7 root 2 x square divided by x. So x and x gets cancelled. So you will be getting 7 root 2 x. So that one plus 7 root 2 x I will be writing here, and 7 root 2 x into x again I will be multiplying. So 7 root 2 x into x is 7 root 2 x square, plus into minus is minus. Okay, then 7 root 2 into root 2x. What happens? See, this one and this one, if you multiply 7 root 2x into root 2, right? So 7 into x into root 2 is 2, right? So you will be getting 14x. I hope you people are understanding. 7 root 2 x, this one I am multiplying into root 2. Already I have taken the minus sign. So root 2 into root 2 is root 4, that is nothing but 2, right? So 7 into x into 2 is 14x. I am writing here, that is 14x. So divided by, I am going to change the sign. So for here it is plus, I am going to make it as minus, and here it is plus. So this is going to get cancelled, and both greater number sign as plus. So plus, so different signs of 14 minus 10 is 4x. And now I am going to bring this one, that is minus 4 root 2. I hope you people are understanding. Now what I am going to do, this 4x minus 4 root 2, again we are going to consider this one. The first term 4x and x I'll be dividing, that is 4x by x. So x cancels, I will be getting 4. So plus 4 I will be writing here, plus 4 into x is plus 4x, plus into minus is minus, 4 into root 2 is 4 root 2. So if I subtract, what happens? So both gets cancelled and I will be getting remainder as 0. Understood? Yeah, I got the remainder as 0. Now this is exact. So I have divided this using one root, and taking one root and I have divided, and this has been happened. So this x6 x square plus 7 root 2 x plus 4, this is a quadratic equation now. Now we have the other two roots, right? So this cubic polynomial has 3 roots. So taking 3 roots, one root we have divided that and it became 0, the remainder became 0, and we got a quotient as a quadratic equation. So now this quadratic form, if we solve further, then we will be getting 2 roots, then altogether we have 3 roots for a cubic polynomial. So I am considering this one, that is 6x square plus 7 root 2x plus 4. Now I am going to factorize this in order to get the 2 roots. How to factorize this? So 6 4s are 24 x square, and I need to take 2 factors, 2 numbers, such a way that if I add or subtract, I will be getting 24x square. Add or subtract, I will be getting the middle term 7 root 2x, and if I multiply, I should get 24. Which 2 numbers should I take then? So let me take 4 root 2x and 3 root 2x. So 4 3s are 12, 12 2s are 24. If you multiply root 2 into root 2 and x into x, yeah, it's perfect. So 4 root 2x and 3 root 2x are the splitting the middle term. By the method of splitting the middle term, if we do, we will be getting this. I have 6x square plus 7 root 2x plus 4. So in the place of 7 root 2x, I am going to substitute these 2 things. So it is the method of separating the middle term. So 6x square plus 4 root 2x plus 3 root 2x plus 4. Let me equate this to 0. Now I am going to take common. So 6x square. Okay, let me rearrange this for better front of simplification. 4 root 2x plus 3 root 2x plus 4 can be written as 2 into 2, right? Or 2 into root 2, right? Can you write like this? So root 2 into root 2 is 2. 2 into 2 is 4. So that is equal to 0. So this one, again I repeat, 4 can be written as 2 into 2 and 2 can be written as root 2 into root 2. The entire value is about 4. So for the simplification purpose, I have converted like that. So now I am going to take common. Here 2x is the common, right? So 2 3 are 6 and x plus 4. So 2 root 2 is the thing. If we again multiply, I will be getting same thing. 2x into 3x, 6x square plus 2 2s are 4. Root 2 into x, yeah, it's correct. Plus here, which is common? Root 2 is common, right? Yes, just root 2 is common. So I will be getting 3x plus 2 root 2, that is equal to 0. So I got 2x plus root 2 into 3x plus 2 root 2, that is equal to 0. So 2x plus root 2 is equal to 0. And 3x plus 2 root 2 is equal to 0. So 2x is equal to minus root 2, plus root 2 comes this, it becomes minus root 2, or 3x is equal to minus 2 root 2. So x is equal to minus root 2 by 2, or 3x is equal to minus 2 root 2 by 3. So these are, you can take further like this is minus root 2 by root 2 into root 2. Root 2 cancels. and here you keep it as it is. So x is equal to minus 1 by root 2 or x is equal to minus 2 root 2 by 3. So these are the roots what we found. Okay, so already root 2 was one of the root, and based on these calculations we have found the other two roots of equation, which means exactly when we divide minus 1 by root 2 what number we are going to get, and also minus 2 root 2 by 3 what number we are going to get, and also root 2. At these three places the curve of this polynomial is intersecting or touching on the x-axis of the graph. Now I hope it was clear and a superb concept. So this way you can take any equation or any polynomial and start solving. If one of the root is given, then you can take that and divide that. If it was a biquadratic equation, they may give two roots or one root, and again if they give one root for a biquadratic equation, then you can go for the synthetic division method or just dividing and taking the cubic polynomial further. The double process of this goes. So this completes the polynomial chapter. So I have completed so far 2 chapters, and in the next video I will be coming up with the pair of linear equations in 2 variables. So a very interesting chapter. I will be coming up with the next video, and I am also a motivational speaker. I motivate people, I go to different colleges, etc. I have another channel also, so you can go to the description and subscribe the channel, and you see you can watch the motivational videos what I have made. So far I have made about the angry management, how to control the anger at subconscious level, and also I spoke about environment. Okay, I hope this was a fantastic and a beautiful concept. If you didn't subscribe my channel, please subscribe my channel and click the bell icon and for the getting notifications. And if you like this video, please like my video and share it, and don't forget to subscribe my channel. We'll have a great journey of mathematics, and in the future videos I'll be coming up with the fascinating science concepts also. Okay, bye, take care, always be mathematically inclined. Bye.